So you were probably coming to this talk expecting to see Miles Ward, and I'm obviously not Miles Ward. So if you came to see Miles specifically, apologies. We're definitely having our user conference reInvent in a couple of weeks in Vegas, and he'll be there. So if you want to hook up with Miles, hit him up there. I'm filling in for Miles, but I wanted to talk about some interesting work that was done on AWS. And I'm going to focus on just one of the use cases today, Obama for America, and talk about how a very lean and small team, and during a very short time period, did some amazing things for Obama's campaign. And so we'll be talking today about, what was Obama for America, why is it relevant, what kind of applications did they build, what were their challenges, and some details about their architecture and how they built on top of AWS. So again, this is Miles Ward. I obviously am not Miles Ward. I didn't shave. I don't play the electric tuba or sousaphone. But it was very interesting. Miles actually worked on the Obama for America campaign. He volunteered his own time and went and helped them build their architecture and leverage AWS as much as possible. AWS does not officially endorse any political candidates, just to make that clear, but Miles had some really rewarding experiences from doing that. So I am John Reef. I do work for AWS. I am a solutions architect like Miles. Again, AWS does not endorse any political candidates specifically. I don't play the tuba. I do play Guitar Hero a bit. That's the extent of my musical abilities. And his tuba does have lights on it. So also, if you ever want to hear him jam, I've heard it's an amazing concert. I haven't been able to get and see one of his sessions yet. But like I said, he'll be at reInvent along with a lot of our other solution architects and customers. So if you haven't already registered, there's very limited space. So get on it, get to Vegas in a couple weeks. OK, so let's jump into what Obama for America was all about and how they ran on top of AWS. So let's imagine that we're getting ready to elect a president. One of the very first things and one of the critical aspects to the campaign was raising money for the campaign. And so they have to raise a lot of money these days to run these political campaigns, and actually so much so that during the campaign time, they became the 30th biggest e-commerce platform in the world. So a crazy amount of transactions, and when you think about that, it raised over $1 billion. And so from the technical team that had to build the infrastructure for Obama for America, they had to design an e-commerce platform that could handle the transaction processing for that level of complexity. And that by itself, if you think of just building that one platform, would be a pretty challenging project for any IT team and any development team. But that was just the start for Obama for America campaign. They had to build actually 200 distinct applications, e-commerce just being one of them, and all the complexity involved in doing that. And when you think about an application, that could be an iPhone application that had the iPhone development, the API, the data store for that application, the systems, the monitoring, the metrics, all just for that one application. And now you have to do that 200 times. And by the way, you have to do that with volunteers for the most part. So most of the developers on Obama for America were complete volunteers. And doing this on nights and weekends. And so it was a pretty big, daunting set of challenges to build these applications. So beyond just those 200 distinct applications, you also had 50 full-time query analysts that were looking at hundreds of terabytes of data to look and see and make the correct decisions about how they wanted to alter the strategy for the campaign and how they wanted to direct the resources of the campaign in which direction and how to ultimately get as much of the grassroots effort up to elect the president. So they had to write a lot of SQL. They had to design a lot of systems to handle that kind of scale, that amount of data, and the amount of queries that were going against that to make the right decisions at the right time. So again, 3 kind of huge challenges there just unto themselves. But you add another layer of complexity in here with the scale and elasticity needed to support something like Obama for America. So when you build a system that's supporting the president and he's out on the campaign trail, and at one moment he mentions a website, boom, you now have millions of users accessing that site at any time. So huge unpredictability of how to deal with traffic to any number of these applications. And the applications involved both, public-facing applications, as well as all the applications to support the volunteer efforts and connect the volunteers and organize the staff. So just a huge, incredible amount of load against these applications. So that's all the fun stuff and really cool stuff. But on the downside was they had very little money to do this, and any dollar that they spent towards IT and towards running the server infrastructure and towards developing these applications was one less dollar that they could use for other purposes for the campaign. So they had to be really extremely efficient. And they had to do all of this in approximately 7 months. So they started 7 months for the vast majority of the IT and development of applications and IT infrastructure. And as I mentioned, 3/4 of this organization was complete volunteers. So it's like, somebody who comes in and says, hey, I want to volunteer for Obama for America. I'm a Java developer. You can't say, OK, go away. We don't have a Java team here. You say, no, come on in. Join the team. Go see the Java guys. Build some application. And so you saw a lot of different application stacks in use, and we'll see how that came together. And you really had to adapt to whatever skills you had on the development team. And then another critical thing was you have one release day. You have absolutely one day that this all has to work correctly, and it takes literally an act of Congress to change that day. You have to make the election day, you have to make sure everything is up and running. How many people in here have never missed a deadline, have never shipped their code? Always on time. That couldn't happen. You should see no hands in here, right? This team absolutely had to make all their deadlines. Everything had to work. Otherwise, they would potentially, not elect the president because of these systems, right? So it plays a huge, important role into running any campaign and a massive set of challenges. On top of that very complicated situation and set of variables was most of this was built by crazy people like Miles, right? Radical programmers that were very young. I think the average age of a developer on the team was 23 years old. So, it was a lot of volunteers. It was a lot of hard work. And actually, most of the guys running ops were the old smelly guys, the old guys from IT operations, and most of the developers were focused on just writing the code. So you can see kind of this complexity of variables creating a very unique challenge for building applications. So not your typical technology professionals, although I see that going a lot more this way for technology professionals. And as a result of this, a lot of these folks actually got hired by Twitter, by NASA, by Netflix, and by others, the architecture team that built Obama for America. A number of them for AWS as well. And of course, there were a lot of ladies involved with the campaign as well. So there's a lot of lead developers for the applications, and a lot of females involved in volunteering and supporting the Obama for America campaign development. It's not your normal office environment. Kind of take your typical startup and just magnify that. It makes college dorm rooms and typical startups look clean and tidy. There were just, imagine this, a developer comes in and says, hey, I can give you a week to work, a week of my time to work on this project. How can I help? How do I integrate that? So it was, a very challenging work environment as well, and made for some interesting team dynamics. And part of the team dynamics is what drove the success of the project as well. So if we dive a little bit deeper and look at the over 200 applications that were built for Obama for America, these ranged in all sorts of different types and complexity. So to give you an example, on the bottom left here is an application called Canvas. And Canvas was a registration app. So if you think of one of the most critical things for getting voter turnout is getting people to actually register to vote and go find out where they should register, how they register, and just getting them off the couch to take some action. And so they had to register a certain number of days before, and you basically had volunteers that would go around and help canvass and find and try to get people to go and register. And so this application was actually a mobile app that would take data and would tell volunteers which doors they should or shouldn't knock on. And part of that was going to a voter registration database and figuring out who was registered and who was not. But they also used some unique techniques like looking at Twitter and looking at Facebook and looking at the voter registration site. If you clicked, hey, I voted or I registered to vote, registering to vote is awesome and I just did it. All of that stuff they would take and feed into these applications to make better real-time decisions for their canvassers. Another challenge was and a reason for that also was those databases about registered voters changed once a week. It wasn't as dynamic as they needed to be able to tell their volunteers and make the biggest impact for their volunteers. So this is just one example of an application, and they would send a team off to build that entire stack, and we'll see what some of those look like and some of the data challenges. They also built their own version of Facebook. So they built their own internal version of a social network that allowed their volunteers to communicate, connect with each other, form groups, share pictures, share information and ideas about how to make a bigger impact for the campaign. They also did this interesting app called the Call tool. You can see it on the right here. And the Call tool was an application where a volunteer would install it on their mobile device. Once they started that application, they would just start getting calls immediately. Calls would just start rolling in, and the volunteers could answer as many calls as they could during that time period. And that system would also look and say, what's the next most critical call that a person should get? And let's route that to a person so that they can ask for more money, they can ask for somebody to volunteer, and that would just run continuously until the person said, okay, I've had enough. I've had my share of answering calls. And so some really interesting applications, and these are just some of those 200 applications that they had to build in 7 months. So some crazy time there. And they built all this stuff, and he won, and it worked. Woohoo! Everything was great. And we'll see how some of that was accomplished and what the architecture looked like. So they built a bazillion charts about what was going on with their applications, some of those in New Relic, to understand how the performance of their applications were being affected and how to tune and optimize them. And most of them look like this, basically a huge sea of pain at the end of getting closer to the election. Like just sea of pain, how do I solve, how do I tackle this enormous scale and challenges of the load that would be driven across these applications. This was a relatively big implementation. Their lead engineer, Scott, tweeted about some of his notable metrics about this. He built most of the architecture and design. So they had a very focused team that worked on some key parts of the application, but then really developers coming in and building those 200 based on their volunteer time. And so he has a bunch of terrible numbers about how complex this was and the kind of scale they were looking at. To give you an idea, 8.5 billion requests processed during the campaign, 180 terabytes of data, 583 days from start to tear down. So another big challenge was actually, what do you do when this is all done? And in 2008, the campaign actually took a year just to get rid of all their old equipment. So a huge part was, how do we scale up really quickly and then when it's all done? Because once we're done with this, he either won or he lost, but everybody's done. Everybody goes home, everybody goes on to their regular jobs, and we got to tear the whole thing down. So a pretty interesting set of circumstances. So how did they go about building this? Well, we talked to them relatively early on. They came to us and they said, hey, we're thinking about using Amazon. And we said, great. We got this website. You could buy a bunch of computers from us. We could even ship them by Thursday if you need them quicker. And they said, okay, yeah, but we will probably have some concerns about we need too many orders, and maybe Thursday isn't fast enough, and maybe we don't know exactly how many of those we need to order, and there's it's just probably going to be a big mess. So, of course, they came to Amazon Web Services instead. And when they came to AWS, they sent us an email, and basically they said, we don't really want to spend any money at all. We don't have a lot of money to spend on IT. But if we do have to spend some money, then we really only want to spend on what we use and what we need for the campaign. And they also said, well, no provider of computer infrastructure is ever going to be fast enough for our needs because we have such tight deadlines. And we need this stuff really quick, and you need to give us some computery thing that gets this stuff done without you having to jump in and fix it. We said, that's an API. You make an API call to AWS. And so, some of the other key challenges were really, they need to scale up and scale down because, as I said, when the election is done, then everybody goes home. So they need to turn all the equipment off. But they also had events like the debates and other events that would drastically change the scale of their website and the need for infrastructure during those times. And so, that was really fit well with a lot of the things we look at from AWS, is how do we optimize infrastructure and provide capabilities when people need them and just for what they need to use. And so pay by the hour, pay for what you consume, scale it up, scale it down. And ultimately, our goal is to make that the most cost-effective solution for anybody, not just for Obama for America, but for really any business of any size. So we built this, and this is a live website. You can bring it up on your mobile devices or your browsers if you want to. It's AWS-OFA.info. It's actually an architecture diagram of their entire implementation on top of AWS. If you've ever gone to the AWS website and looked at some of these architecture diagrams, they're usually like 10 or 15 components. This has hundreds and thousands of individual components, too small to see on this screen. But if you bring up a web browser and take a look at it, you'll see the complexity involved in such of an IT system. So, they followed a lot of the traditional best practices. Frankly, all the AWS best practices, or even things you're going to do outside of AWS, they made multiple machines for availability and for failover. They used availability zones in AWS to make sure if something happened in one of our components that it didn't cause a failure in their application. They created queues, and they distributed work across those machines and then put data from those machines into queues that would provide some flexibility and some some elasticity to ingesting incoming workload. They put data from those queues into databases, and they read that data back out into pre-computed views and to be able to answer questions about what's going on with their data and how are these applications being used. And then once all that done, they went home and partied, right? Once everything was a success. But they followed a lot of the typical best practices, and if you look at this architecture diagram, you'll see a lot of those in play. And the same as what's on our website, awsamazon.com/architecture, gives a lot of those typical best practices for scale-out, stateless design, and building applications on AWS. To give you an idea of what some of their data systems look like, they had very giant data analysis and high throughput systems that were required. So on the left, and this is just basically blowing up part of that diagram, you'll see a SQL-based data store. This SQL-based data store had about 28 terabytes of data in it. It had, at peak, about 526,000 I/O operations per second, and about a terabyte of memory or so in that cluster of SQL. And they started building on those relational database cluster, and then when that couldn't meet their need or became too complicated, they just went to Dynamo and used a few lines of code and let us take care of the scaling as well. So they partitioned and used multiple data store strategies depending on their workload. And in the Dynamo system, they actually had 200,000 IOPS. And in fact, they built 11 different subsets of these type of systems, dependent on what application they were building and what were the back-end data store needs for those applications. One of the most important parts, and something that we helped them build, was this front-end API abstraction called Narwhal. And Narwhal was a critical piece to the success of the overall architecture, because it was really a back-end that abstracted out, an API that abstracted out the back-end data that was hosted by other third-party services. So This system would actually call out to all sorts of different third-party systems, processing payment systems, collecting map data, collecting voter registration data, looking at social data. So you could imagine there was a lot of complexity in dealing with all those third-party systems. So really the core engineers on Obama for America focused their attention on Narwhal and focused that for a number of reasons. One was so that no single service had to implement every time against each of those data stores and consolidate it. But also those data stores or those backend APIs, if you sent the kind of load that Obama for America was gonna direct at those services, could actually take those services down themselves. So they had to really focus on making that a key part of the architecture and making that a scalable mechanisms for all these 200 application developers to leverage a common source of backend data. And so you can see this is kind of a example of all the different types of applications they had to build. They had to build websites, they had to build communications applications, ad targeting applications, ops tooling, analytics. And in most cases, they were really looking at making the decision that would make them move the fastest. How could they not spend time on things that wasn't important, and how could they excuse me, how could they focus their attention on building the cool applications and the needed applications? And they really had to prioritize that. And as a result of this unique population of developers, they used almost every conceivable piece of open source software. This is an example of some of them. Some of them commercial, some of them open source. And a lot of this also was driven because of the diverse set of developers that they had that were mostly volunteers. And so you see some examples up there. If you look at the data stores, they had all sorts of different types of structured data store systems. And it was really dependent on the application team's strengths and the needs of the workloads. So again, they took a very SOA-based approach, services-oriented approach, and really geared it towards the strengths of those individual teams and what languages they knew and what data stores they were comfortable, coupled with what fit the application the best as well. So they had, MongoDB running on EC2, Postgres, RDS, Vertica. This was before we had Redshift, so they probably would have used a bit of Redshift as well for analytics. DynamoDB, SQL Server, HBase, pretty much every conceivable data store was in use at a pretty reasonable amount of scale as well. Also development frameworks. Like I said, if somebody came in and said, I know how to program Node, you couldn't just turn them away. You had to figure out something that they could build and how you could incorporate that into your applications. And also as a result, they had single applications that were polyglot applications that were combining different languages. So they had applications that may had a front end with PHP, but then other portions were Ruby on Rails, and another portion of it would be Node. And so it was a really interesting use of the languages that are popular today. So because you can imagine, because of this complexity of the situation, they had a lot of concerns of the things in dark gray on this slide. So they made these technology choices like polyglot development, like hosting on AWS to give the flexibility and scale and cost effectiveness that they needed. But they also had this diverse app-centered database approach with all these different types of databases, and they had an SOA queue-based system, and they had a lot of junior developers, right? They had a lot of people that didn't have a lot of experience. So bringing all this together, they had the concerns that were in the middle, which is, are we making operations more complex because of this diversity? Is it going to be too fragile? Is it just going to fall apart? Is development going to be more complex or slower because people are learning SOA or queue-based systems? And the interesting thing that they found was a lot of those choices actually had the reverse. They had a lot of upside from those choices. And of course, they put a lot of focus into those really critical parts of their infrastructure, like Narwhal, that made that run efficiently. But they actually saw that they were able to scale much faster, be cost effective on AWS, of course. But they were also able to automate a lot of these processes to gain flexibility and operational control. And we'll talk about a couple of the other approaches that they took. Game days was really critical as part of their planning. But they actually saw a lot of upside from these choices, where initially they were concerned about it failing, about it not succeeding. And really, they only built the critical applications. They really focused on what are the most critical applications to elect the president. And so they had a laser focus. And we'll talk about fail forwarding strategies as well, something they used as part of their deployment process and their integration process. And they had no time to waste. I mean, the time deadline was there. They absolutely had to meet it. They had to make infrastructure changes all the time. This was continuously available. If they need to deploy a patch during the debates, they had to do it, right? They had to deploy it. So there was a lot of critical systems, highly available systems that they had to maintain and scale. So one critical choice that they made, and this is partly AWS, but partly beyond, including making choices like New Relic, was they could have gone with the approach where they would do things like install HA proxy and configure it, and everybody knew, lots of people on the team had those skills and knew how to do it. Same thing with MongoDB. They could have chosen to, in some circumstances, go with MongoDB and install it and configure it and deploy it and make it scale in AWS. It would work great. Miles actually has a great paper on that. If you're into Mongo, definitely check that out. But that was time that they couldn't spend. They had to focus the developer time and their operational time on how do they get the most out of their money and how do they get the most out of their time. And so those, if they made the choice to build those systems themselves, instead of leveraging things like New Relic or Elastic Load Balancer or Route 53, then that was another piece of their infrastructure that they just had to think about. How do they get the expertise? How do they research it? How do they devote the time to building it and the money and the risk tolerance? And how do they scale it and make it highly available? Like all of that stuff was just things that really didn't make an impact to their success or failure. So they made a critical early on decision to leverage as much existing stuff as possible, open source software, services from AWS, commercial software, to be as scalable and available and as fast as possible. And so, one tool that they used was New Relic, and it really helped them identify those pain points quickly. Some of the metrics that they gave us was the first time that they turned on New Relic for Narwhal, they realized that they had a 10-row table containing all consumer keys, and it was causing a big slowdown in their queries. And so they actually, within 30 minutes of turning it on, they made a patch, understood that that was causing a major bottleneck in their application, and they reduced from 160 milliseconds their requests by 100 milliseconds. So it was actually an 80% increase. So they really took that approach of rapid development, of service-oriented architecture, of scaling as they needed to, and of monitoring and doing game days to the max. And we'll see what some of that looks like. To give you an example of this, one of the trade-offs they made, so with Mongo, again, I could install it on EC2. Miles' paper is great. It takes about 14 steps to go through and install it. You could probably do it in like 10 to 15 minutes on an EC2 instance. But with Dynamo, if it fit their needs from an application development perspective, I could do it in less than 8 minutes. I could actually insert 7.5 million records and actually have my data operational without patching it or scaling it or making it available or anything. So they really focused on a lot of the AWS services that took that heavy lifting off, and they saw a good trade-off between the cost and the benefit that they got from doing so. So to give you an idea of some of the other scale from Obama for America, this is an interesting slide we like to talk about of AWS's scale, and you'll see on the next slide how that relates to Obama for America is when Amazon.com was in 2003, the retailer, we were about a $5 billion business at that time. We had about 7,800 employees, and we had a ton of servers to support that infrastructure, right? Typical e-commerce website. AWS today, actually this is from a 2012, so it's even higher now, adds enough server capacity to power that entire business on a daily basis. So the amount of infrastructure that we're rolling into AWS to power the growth of other companies is extreme and enormous today. To give you an example of this for some of our services, in 2006 to 2008, SQS had thousands of customers, a ton of servers supporting that service, the Simple Queue service from AWS. and over 5 billion queued events during that time frame. Fast forward to 2012, when Obama for America used SQS, they produced 8.4 billion events by themselves, just for that campaign, just in the time period of the 7 months of using SQS. So extreme scale. And when you look at these type of services, and actually this was just in the last month of the campaign, it wasn't even the entire 7 months. So when you look at using some of these services, one of the key trade-offs on AWS, and something that I talk about as a solution architect when I go and meet with customers, is how do I optimize for cost? One of the key things, whenever I have a discussion with a customer, it always comes back at some point to, how do I get the best price performance? How do I optimize for cost? How do I design my system for cost? And so this is an example. A lot of customers will start using AWS just like any other provider. They'll, again, spend time and effort and deploy infrastructure on EC2 instances. They may take RabbitMQ and install it on EC2 instances and work on scaling it. Where if SQS meets your needs, it's a much simpler solution to implement and to operate, but it also has this added benefit that you pay based on the number of requests. Whereas with EC2, you pay on EC2 hours, right? And so when you look at that at scale, that quickly becomes a really expensive proposition to run that on EC2. Whereas on SQS, it's just a flat cost. Every 10,000 requests I make costs a fixed amount. So that's a really important thing if you're looking to optimize your usage of AWS. Talk with the solutions architect, talk to an account manager, have them come in and look at how to make recommendations on how to reduce your AWS bill and what kind of services you could use to do so. Another interesting thing that happened during the campaign was this was a map of the weather 11 days before the campaign happened, before Election Day happened. And you can see our data centers are right about here, and that's too close to our data centers for comfort, right? So they were deployed in US East region. Hurricane came through and caused a lot of concern for the campaign. They had all of their infrastructure deployed there. And so they put in a mitigation strategy because the head of their campaign, overall, the head of Obama's campaign sent the IT team this cake. And that team, they really wanted to eat this cake. They didn't want to censor this up. They really wanted to be successful. And so they mitigated that concern over the weather 11 days before the election. And they had deployed this infrastructure took about 3 months to build this overall infrastructure in US East. And it was running well. All the applications were performing well. But to mitigate that concern over availability that could happen in US East because of the storm, the way they did this, by the way, is they used Puppet. They pre-built configurations. They saved them as Amazon Machine images. Netflix has a lot about this as well, which is basically like the AMI factory type of strategy. And so they used that to build this initial environment. But with this bearing down on them, they decided to spin up a backup plan and to use on the other side of the country, in our Oregon region, they decide to spin up a whole nother duplicate of their infrastructure. And they did this in about 9 hours from when they made the decision to get a backup plan in place to when it was actually ready to go in the other region. The data had been moved. It took them about 9 hours. They accomplished this by using Asgard and Puppet to build a version of that infrastructure in US West, to take all the AMIs that they had built, all the configurations, and duplicate that in another region in AWS. This was about 560 instances. They moved about 28 terabytes of their most critical data across the country in less than 9 hours. And a really interesting thing about this approach is anybody could do this. This was a bunch of college kids, volunteers that chose the right tools and implemented them in the right way. And for most customers, you're not going to be at this scale of moving that amount of data. They used Tsunami and UDP as the protocol to move the data across the country. And to give you some idea of that, to replicate across the country, they spent they used CC2 8XL or CC2 8XL instance types, and each of those instance types was moving about 480 megabit per second across the country from one region to the other. So in aggregate, each of those instances was pushing about 1.72 terabytes an hour. And in fact, the data movement of that migration only took about 4 hours of time to move the 28 terabytes. And they did that through parallelization and through the open source tool Tsunami. And you can see the URL there if you haven't seen Tsunami in the past. So some really cool stuff going on. I highly recommend a lot of caffeine if you're going to do some marathon, like a 9-hour migration and replication of your infrastructure from one AWS region to another. And you really can't stress that enough. A lot of caffeine to get you through that. Another interesting part was security. Security was really important for the campaign. Obviously, you couldn't have any of these sites vulnerable, also from just raising money as well as disrupting any of the campaign operations, right? It's part of our democratic process, and you have to treat security of these systems just as important as any other facet. So they had some international security experts that they brought onto the team for Obama for America. And some of those experts would basically go through and hack improperly built sites and replace that vulnerable code that they found with an animated GIF of this sea otter. And so the developers would see that and know that they had some work to do to fix that. So just because they were moving so fast, they couldn't sacrifice security. So they took a lot of our security best practices from AWS and incorporated that into their operations. But they also had a really big focus on securing all of the applications and testing them to the max. And then game days were critical. So I know I'm getting close to the end here. And if there's any questions, by the way, I can take them offline because a lot of content to get through in the time we had. But a really important aspect that they had was game day, where they would practice all the different failure scenarios. And you probably read about this with Netflix as well. But they would have kind of one group of the developers that would be the good guys. So like you guys would be the good guys, and you guys would be the bad guys. And the bad guys would go in, and they would be given a set of AWS access keys to do things to the infrastructure, and they would just maliciously go in and delete EBS volumes and shut down EC2 instances and delete SQS queues and delete SSH keys. And they did that with a lot of rigor so that when things actually happened during critical times, they knew exactly the steps to take to fix a piece of critical infrastructure. And they really isolated critical pieces of the infrastructure with loose coupling to really enable them to scale. The fail forward is actually also a very interesting approach where they basically, their approach was if code broke in production, there was no rolling back. Because they were under such critical time schedule and because every application was critical, they decoupled the applications as much as possible. But if an application broke, that team would just spend an all-nighter and fix whatever was wrong with that application. There was too much complexity to try to coordinate releases. It was basically a complete continuous integration, continuous deployment environment. And each team was responsible for their entire stack, top to bottom. The front-end infrastructure, the data tiers, the operations, the monitoring. And so they had to leverage a lot of pre-built solutions for that. As a result, a lot of new companies were born from the campaign. As I mentioned, a number of the folks moved on to other technology companies, but also a lot of new ventures were born from the people working on the campaign. And really, what will you do next? AWS is a really interesting environment. It enables a ton of innovation for you to basically start up anything with very little amount of money and to scale it to any level that you could imagine, really. So definitely, they actually put all their code up available on GitHub. So you could check out a lot of the code from the campaign. And I have stickers and my cards up here. Again, apologies, you didn't get the fantastic Miles Award today. And Miles is definitely somebody you should check out in the future if he ever comes back to the Bay Area to speak, or if you're at reInvent, check out one of his sessions. So thank you very much for coming to the talk.